Okay, so hello everyone, I welcome you in this particular video. In our previous video regarding the playlist Laplace transform, we discussed about a derivative property, multiplication property, change of scale property, fast shifting property, basic derivation and many more. So particularly in this video, we are going to learn the integral property. In the previous video, we discussed about the derivative property. That means how you can find the derivative of a particular factor's Laplace. Now in this particular video we are going to learn that how you can derive the Laplace of any particular functions or factors integral. Okay, so if you kindly follow the derivation, all the things will be crystal clear to you, because derivation comes under your mind, right? So if you practice the derivation, then all the things will be crystal clear to you. So I will highly suggest you to follow the derivation and then solve the example problems, right? So in this particular video, we are going to learn the derivation property of derivation of the integral property of Laplace, and we will see one example problem based on that. So without wasting time, let's get started. Okay. So Laplace of f of t is f bar of s. As I discussed in our previous video, for our convenience, we are writing that f bar of s. So we cannot write the whole thing like at this long method. So for our convenience only, we are writing because it's a function of s. So we need to prove that Laplace of integral 0 to t f of t dt will be 1 by s f bar of s. So for that, let's put this whole factor, integral factor, to a new variable or new factor g of t. So g dash of t will be according to Newton-Leibniz rule. According to Newton-Leibniz rule, Newton-Leibniz rule I uploaded on this particular channel. You can watch and search the title Newton-Leibniz rule of integral and our channel name. Then you can find, you can access. If you don't know, then particularly watch that video and you know. So then follow this. So g dash of t will be, right, you put the upper limit over here and get the derivative of the upper limit. The derivative of t with respect to t is 1, minus you put the lower limit and you get the derivative of the lower limit 0 का derivative तो 0 ही होता है. So g bar of t will be f of t, right? So at t is equal to 0, g of t will be 0 to 0. Upper limit and lower limits are equal, so g of t will be 0. So Laplace of g dash of t will be s into g bar of s minus g of 0 by the derivative property of Laplace, by the derivative property, right? So s g dash of g bar of s minus g of 0 is basically 0. So s g dash of 0. So Laplace of f of t, g dash of t is nothing but f of t. Laplace of f of t is g dash of g bar of s. So g bar of s basically 1 by s into Laplace of f of t is basically f bar of s. So f bar of g bar of s is basically Laplace of g of t, right? So Laplace of g of t is nothing but Laplace of g of t was 0 to t f of t dt, that is 1 by s f bar of s. Now see one example problem derived this is. I hope you understood. Are you getting? If you are not getting, kindly let me know in the comment section. I will give answers separately. So Laplace of sin t is basically a upon a square plus a square, so 1 upon a square plus 1. So Laplace of sin t by t, that is division property. That's why I learned this property, because all the properties are interlinked to each other. If you don't know particular any property, you will be like perplexed over the time. So 0 to s to infinity ds by a square plus 1, and this come out to be tan inverse s to infinity. Tan inverse of infinity is pi by 2 minus s, minus tan inverse of that results cot inverse of s. So the thing will be, if you find the integral, so 1 by s into f bar of s, that is cot inverse s. So it will be final result, final answer. So I hope you understood this particular property and derivation of this particular property. I will highly suggest to go through this derivation, because if you scan through the derivation, all the crystal or your clarity becomes 100%, right? Because you know the origination, you know the how this property has been derived, right? Then particularly solve this example problems, right? And if you know all the properties of Laplace, then calculations will be very much simpler for you. So for our convenience only, we are using these properties, right? So thank you for watching this video. If you have any particular doubt, let me know in the comment section.